In this lesson, we'll learn how to access databases using the SQL tag library in JSTL. There are only 6 tags in this tag library, so it's pretty simple to use. As usual, we'll start with a simple example. Let me show you the database table first. And again, I'm going to log into my local database. And the table we are going to use is this items table with milk, beer, and something else. This time, we're going to access that. We are going to display the content of that table using this JSP page. Notice that this JSP page uses the SQL tag library from JSTL and is supposed to display the content of the table. Let us run that. And it shows the content of the items table: milk, beer, price, quantity, and so on. Now let's go over a few things about this example. First, notice the taglib directive here. This imports the SQL tag library from JSTL in this page, so we can use the tags from that library. The setDataSource tag sets up the database connection that we'll use to run queries and updates. Just like in JDBC, we need the driver, the URL of the database, the username, and the password. The setDataSource tag also has a few other attributes: var, scope, and the data source. Those can be used if you have multiple data sources, or if you want multiple JSPs to use the same data source, or if you want to use an existing data source from a directory service. We'll keep things simple and let each JSP use its own data source, so we don't need those attributes, just the basic ones: driver, URL, user, and password. Once we have a data source, we can run queries using the SQL query tag. The results of the query are stored in a variable specified by the var attribute, and the query itself can be specified either as an attribute of the SQL attribute or as a body content of the SQL tag. For example, for short queries, it's easy to put it as an attribute, but if your query is pretty long, you can put it as the body content of the SQL query tag, or in other words, put it between the opening and the closing tag. It will work the same way. And just like JDBC, the tricky part is to get the data out of the results set. If you look at the code, it's not quite clear why the result shows up in this way. Okay? We go through the rows, and for each row, there's something called a key, something called a value, and somehow it comes out not like in a table as we would expect. It comes out as something like this. And the key to understand this is to realize that the result of a SQL query tag is the object of this type. And if you read the API documentation of this type, you'll see that it's actually an interface, and you can see that this interface defines a number of getters. And this is basically how we can get the data out of the data set of this result set. For example, because we have a getter here called getRows, and this is why we can say items.rows, and remember that items is the name of the result set variable, and items.rows basically is calling the getRows getter. And we can see that there are other getters as well. Get column names, get row count, get rows by index is limited by max rows, and so on. Most of them are pretty easy to understand. For example, get rows by index returns a two-dimensional array of objects, and it's easier to imagine this would be the results of a query because a table would look like a two-dimensional array, and also the get column names returns a string array, and it also makes sense that if we want the column names, it's returned as a string array. If we look at all these getters, the only one that needs some explanation is actually this getRows. The result of this is an array of sorted map, and you might be wondering what exactly is this sorted map. Well, this is what it would look like for our items example. Notice that the whole result set is an array, and each element in the array is one row. Each row is represented by a sorted map, where the map key is a column name, like name, price, quantity, and the map value is a column value, milk, 389, 2, and so on. The map is sorted in alphabetic order of the map keys. So the key entry order is name. So the map entry order is name, price, and quantity. And once we understand this, the results now makes perfect sense. If we look at the code, we can see that this outer for each loop iterates through each rows. Remember, each row is a sorted map, and for each row, this inner map iterates through each map entry, and for each map entry we have the key and value, and that's why the result shown here would be this is the first row, this is the second row, and for the first row the map entries are key value, key value, key value again. And this is why we get this results here. Now that we understand how to use getRows, it still feels a bit strange to think of query results as an array of sorted maps. It's much more natural to think of them as tables, or in other words, two-dimensional arrays. So let's change this code to use getRows by index. This will return the results as a two-dimensional array, and it's more natural to use this one in most cases. So here, instead of saying items rows, we'll say items rows by index, and that's because the getter is called getRows by index. And in the outer loop, we iterate through each row, and notice that now each row, instead of being a sorted map, each row now is a one-dimensional array now. And then for each row, we'll have we iterate through each column, and now each column now is just a single value. It's no longer a map key. So what we'll have is something like this. For each row and then for each column, we'll say, okay, so each row, now the table row should be outside. And inside each row, we have the columns, and the columns now, a column is now just a single value, so it's just column by itself. And so now it looks like a table. So we can put a border on it. And now it looks exactly like a table. And we can even add the column name row. So we'll do something like this. So add a header row. And this header row will iterate through all the column names. We'll say items dot. Remember, there's a getter called get column names. So we'll say items dot column names, and each bar is a name, and putting the column name there. And that's it. So running a query is pretty simple. The main thing is to understand how to retrieve data from the result set, and keep in mind that the result set is of this type, and these are the getters, and we can access them as properties in expression language. Okay, now suppose we want to change the query, and right now it will display all the items in the table. Let's say that we want to change it so that the user can specify a price limit. So maybe I want to say I only want to see anything that costs less than $5, and I'll specify the price limit as a request parameter, and then the query should include that request parameter. Well, it's not too difficult to do that, and we know that all we need to do is to change the query a little bit. So instead of select everything, we'll say select star from items where price is less than price, something like this. So if we specify price is 5, and only milk should be shown. Okay? And that's exactly what happens if we increase the price limit to 10, and it will show beer as well. Now, remember when we talk about JDBC, we said that we should never trust user input, because A, there could be special characters in the user input, and B, there's the danger of SQL attack. So that means in Java code, you should never create your SQL statement by doing string concatenation. And similarly, if we do it in JSP like this, we are essentially just doing string concatenation again, right? And a user, for example, could try to trick us by doing something like price is this, or and something like this. So that again could expose our application to potential problems and security attacks. So this is of course not good. So how do we do it the right way in JSP? Well, in JSP, there is something similar to prepared statement in JDBC, and that's the SQL Prime Tag. So instead of doing string concatenation to create the SQL statements, we can again place placeholders in the statements and then insert the actual parameter values into the statements. And here we'll use the SQL Prime Tag. So in our example, instead of doing things like this, we'll say less than question mark, that's our placeholder, and then we'll say SQL Prime, and value is the parameter price. And now it will work as before. Well, what would happen if we do this? Yeah, now nothing is shown. And if we do this one, it's worked correctly. So again, this is very similar to prepared statement in JDBC, and anytime if part of your SQL statement depends on user input, you should use this form in SQL tags and prepare statement in JDBC, of course. By the way, notice that SQL Prime Tag doesn't have an index, which means that the order of the Prime tags determines which value gets inserted in which placeholder. So this one will be placed in the first one, and this one will be placed in the second one. Okay. Again, now that we know the basics, it's time to do guessbook again. And this time we'll use the SQL tag library in JSTL to do our guessbook. If we go through our previous code examples, we already did guessbook in Model 1 architecture, and this one uses mostly text and expression language to do the guessbook. So we'll do this again, except that this time we won't be using any bin because the data now is in database. So I'm going to use that code, and I'm going to change it a little bit. So let me stop this one first. And let's copy over these two JSP pages. And for guessbook, there's no bin anymore. We need the core. We also need the SQL. So this one will be SQL, and this one will be SQL. And let's change this one to JSTL SQL. And let's remove add comment for now. We'll get back to that later. And so, okay, we'll leave this here for now. Okay, in our previous example, the data is stored in application scope bin, and now we have our data in databases, and we already have the database table from the JDBC lesson. So I have my table guessbook here with ID, name, message, and so on, and there are 4 entries right now. And so let's do a query, of course. So we'll say SQL query, and var, that's the name of the result set. We'll say this one is entries, and we'll run to our query, and the query is simply select star from guessbook. Okay, so now we have our query, and Well, we can actually still do this check. And in the result, there's actually a getter called getRowCount, and this one gives us the total number of rows in the results. So here we can say if entries.rowCount is 0, that means there's no result in the result set. We'll say there's no messages yet. And if entries row count is greater than 0, we do our display here. And there's no index. There is ID though, so let's display the ID. ID, name, message. In this example, we don't have date, so we can get rid of date. And we'll use rows by index, like in the previous example. So we'll do for each entries dot rows by index, and that each one is a column. No, each one is a row, and we don't need var status. And then inside each row, we do each column. We say items is a row. Remember that rows by index is a 2-dimensional array, so row would be a 1-dimensional array. Var is column, and then this one is simply column. And this should be it. Yeah, looks reasonable. Let's give it a try. And guessbook.jsp. Oops. What does the error message say? Unable to get connection. Oh, forgot to get a connection. That is, of course, this part. We'll define a data source, and then we'll do our query, and then it should work. And what it does. So this is the display part. It's more or less the same as the previous Hello SQL example, just a simple query and then going through the results using rows by index. Nothing too special here. And then let's add the add comment part. Let's grab this file here, and this is our EL and JSTL and bin version. We no longer have bin, so get rid of that. And this time we'll set the data source here right away. And we also need the tag library, SQL again. Okay, so now we have our data source, and this part is supposed to add a new entry, so it tests whether there's a prime add. If there is, it sets the prime name and the message. Okay, so this is a part where we need to do a insert statement and insert a new entry into the guestbook table in the database. So we still have our prime name, prime message, but this time we'll need to do an insert. And just like in JDBC, queries and inserts use will need to use different things. And for query, we use the tag SQL query, and for inserts, we'll need to use a different tag, and that's the SQL update tag. So the update tag, which looks like this, you say SQL update, you say the statements, and then you do the prime thing. And if you want, you can store the returned value of the update statement in a variable. Most of the time, we probably don't need to do that. As I mentioned in the previous lesson, the returned value of an update statement is typically an integer indicating the number of rows affected by that statement, and that value is really not all that useful. But anyway, so here we need to do a SQL update, and we'll say insert into guestbook, and we insert message and name, and the values question mark, and SQL Prime value. The first value is the prime name, and the second value is param message, and that should do it. And we still want the redirect here. And once again, notice the way we construct this statement is the prepared statement style. We have the placeholders, and then we set the parameter values later. And the rest of the code should be pretty much the same. It displays the form, and then it submit to itself, which process the parameters here. Okay, let's try this. Refresh and add comment, and CY says hello, says hello again. It shows hello again, and hello again here. And let's try give it a special character. It's really is a great site, and the single quote is properly handled. It's here, and that of course is because we are doing it the right way, using param, using prepare statement, and all that. Okay, so this is how we can use the SQL update tag. Now we know both JDBC and SQL tags. The question is, which one do we use? Well, we know that the SQL tags are a lot easier use for sure if you compare the code that we have here to what we did before in the JDBC version. As you can see, there's a lot more code here than here, and that's because in SQL tags we don't need to do things like create statement, and we don't have to handle exceptions. We don't need to worry about closing connections and so on. Overall, SQL tags takes a lot less typing to use than JDBC. With that said, we also know that using SQL tags mixes presentation with processing, and obviously it's not good for more complex applications. By the way, it's raining outside, so if there's more background noise, I apologize for that. Okay, so the bottom line is that use SQL tags if the application is simple and the tables are small and the operations are mostly straightforward, like what we have here. It's basically an insert and a selection here. But for more complex applications, it's important to have a good structure of the application for long-term maintainability. So use MVC and JDBC for more complex applications, and if you need a quick and dirty solution, use JSTL and SQL. Now, in terms of this particular class, you may consider using JSTL SQL tags in labs and exams, for example, and you should use JDBC and MVC for homeworks. So this is more or less it regarding what I want to cover about the database accesses. And we have covered most all the basics, but there are a few advanced topics that I want to quickly mention, and I want to give some pointers here so that you know what they are and where you can find them in case you need to use more advanced techniques or tools later on. The first thing I want to mention is transaction. In database operations, we often need to group several SQL statements together, so the database system will treat them as one single operation, and we can do that using so-called transaction. In SQL tags, you can simply put multiple query and update tags inside the transaction tag. We didn't really cover the transaction tag, but it's a pretty simple tag. You just use an opening tag and a closing tag, and then put query and update tags in between, and that's that. If you use JDBC, you can create a transaction by disable the auto commit in connection, and then you can run multiple queries and or updates, and then call the method connection.commit to complete the transaction. For transactions, database systems guarantee ethnicity, consistency, isolation, and durability, which are known as the ACID properties of database transactions. And these are actually pretty important properties. And we don't have time to cover all the details in this class, of course, but you should already know this either from the earlier class or some classes like 422, which discuss more about this type of things. Another thing I want to mention is about the so-called connection pooling. Opening a database collection is actually one of the most expensive operations in Java. So far in our sample code, we would open a connection, run a query or update, and then close it. This is very inefficient, and it won't work well in a real-world application. A good solution for this is to use a so-called connection pool. A connection pool keeps a number of open connections, and whenever you need to run an SQL statement, simply grab a connection from the pool, run the statement, then release the connection back to the pool. This avoids the overhead of constantly opening and closing connections. A good connection pooling library also helps you manage the connections. For example, it can automatically increase or decrease the number of connections in the pool based on the number of requests, recycle connections if they have been idling for a while, and so on. So use a connection pooling library, if possible. And last but not least is the concept of ORM, or Object Relational Mapping. Once you start building non-trivial applications, you'll realize that there's a mismatch between your Java objects and your database tables. And this is essentially a mismatch between the object-oriented paradigm used by many programming languages and the relational paradigm used by database systems. This mismatch can create lots of practical difficulty in application development, as you have to constantly converting back and forth between your application objects and your database tables. Object relational mapping tools are designed to address this problem. If you have time, learn an ORM tool like Hibernate. It will make database application development a lot more enjoyable. And this is the end of this lesson. See you next time.